Welcome back to my room at Chetburn Road, where this time you'll notice although the blinds are down, the fluorescent light tubes are on, giving us a nice level of illumination in the room. But what I want to do is I want to add more illumination to the room today, and I'm going to do that by turning on a 12-volt bulb. There we go. Brilliant. Okay? Now that's what we're going to learn about in this video. We're going to learn about some simple circuits, because ever since I entered the sort of, live fast, party hard lifestyle of a secondary school physics teacher, I found that circuits are something that people often find quite confusing. Okay? So, last lesson, as I say, we learned about fluorescent tubes, last video, obviously. This time we're going to learn about simple circuits. Now I learnt a few things from the last video as well, and by posting it online, one of the main things I learnt was there are some very angry people on the internet. Okay? So, quite a surprise for me, the strength of feeling some people had about that last video. So what we're going to learn about is circuits, and one of the real problems I think with circuits is that at some point in your life you might have had a lesson based on this, which is a supposed model of circuits. Now the model has got a supermarket down here, it's got a bakery up here, and there are trucks going from the bakery to the supermarket delivering bread. Oh, there's some traffic observer for some reason there as well. Now, I think this is an incredibly confusing way of teaching circuits. So, I don't like it at all. Electrons have got nothing to do with trucks, and really electrical energy has got very little to do with bread. So what we're going to do with this model is I'm going to introduce you to one of my favourite bits of equipment in the classroom, which is the cuboid filing receptacle. Okay, there we go, that's that there. Oh look, formula triangles. They can go into the cuboid filing receptacle as well. Okay? So we need really for circuits to know two things. We need to know what a current is, and we need to know what a voltage is. And if we understand those two things, then circuits are really quite straightforward. Okay? Now after posting my last video online, I did get various colleagues coming up talking to me about it, which obviously I enjoyed immensely. And one of them suggested that what I should include in my videos is Walt and Wilf. Now originally I got very excited by this, no honestly, and I thought this was a great idea. But it turned out that I was in fact thinking of Waldorf and Statler from the Muppets, and Walt and Wilf are something to do with learning objectives or something. Okay, so what we're going to do is, as I say, we're going to learn about circuits, particularly how the current and the voltage vary around them. So the first thing we need to know is know what a current is. This is the formula which defines it. So current, is the rate of flow of charge around a circuit. Okay, voltage is the energy provided per unit charge. Now the voltage is often called the potential difference, and that's an electrical potential difference, and that sort of gives us a clue to what it is, and we'll talk about that later. Okay? So, first thing we need to do is we need to know how the current varies around different circuits. Okay? So if we go back to my circuit that I switched on earlier, if we switch that on, what we have is we have a current flowing along the red wire, going through the bulb, and then flowing back to the power pack along the black wire there. Okay? Now the point being, if we look at that as a circuit diagram, okay, this current has only got one way to flow. So it goes from the positive terminal of the battery, which on a circuit diagram is the big line, and it follows the wires round, goes through the bulb, and then back to the negative side of the battery. Now we always say in physics that current flows from positive to negative. Now this is a convention, so it's often known as conventional current, and really it's wrong, because when we discovered electricity, we didn't actually know what it was, so we guessed it was something that flowed from positive to negative. Now, several years later, along came a very clever scientist called J.J. Thomson, who discovered the electron. Okay, electrons are negatively charged. Pretty soon after that, it was obvious that it was actually electrons flowing in the circuit. Because they're negatively charged, obviously the electrons go from negative to positive. But when we're talking about current, it's always positive to negative. That's something that chemists very rarely let physicists forget, that they discovered the electron. So yes, well done chemists, you discovered the electron. Physicists discovered everything else, except of course for pencil crayons, which were discovered by biologists. I'd better remember to disable the comments for this video straight away. So, the current comes out there, round the circuit, and back to the battery. Now, because it's only got one way to go in that circuit, the current is the same all the way around it. Okay? If we look at a slightly more complicated series circuit, there we've got 2 bulbs. Once again, the current would be the same all the way around that circuit because it's only got one way to go. So it comes out of the positive end, round the circuit, and back to the negative terminal of the battery. Only one way to go, so the current's the same in every point in that circuit. Okay? So, let's have a look at the voltage. Now, this is what people find confusing. The voltage is the electrical potential given to the current. Okay? So, if we go back to our definition of voltage, which remember is E over Q, sometimes written as W over Q, where W is the work done, which means the same thing as energy transferred. The potential difference is the energy per unit charge. So if we go back to this circuit here, in the cell, each unit of charge gains 12 volts of electrical potential. Now it has to get back to 0 by the time it's got round to the other circuit. So it goes along the wire. Now we're assuming that wires have 0 resistance, so it never loses any energy or any electrical potential in the wire. It's only when it gets to the bulb then that it has a chance to lose electrical potential. So because it gained 12 volts in the cell, it now has to lose 12 volts across that bulb, getting back to 0 by the time it gets back to the negative terminal of the battery. Okay? In a slightly more complicated circuit, we've still got a 12 volt cell, but this time we've got 2 bulbs. So the current comes out to the positive terminal. It's going to lose some potential over the first bulb, and it's going to lose some potential over the second bulb, but it's got to get back to 0 by the time it gets back to the negative side of the battery. If these bulbs are identical, which at GCSE they will have identical resistances. And as such, the 12 volts will share itself equally between the 2 bulbs. So in this circuit, the voltmeter there would read 6 volts, the voltmeter there would read 6 volts, so the charge gains 12 volts in the cell, loses 6 volts across the first bulb, loses 6 volts of potential across the second bulb, and gets back to 0 by the time it gets back to the negative terminal of the battery. Okay? So, if we have a look at what that means in terms of circuits, right, there's our circuit with 1 bulb, nice and bright. There's our circuit with 2 bulbs. Now these are not identical bulbs, and you can tell that because they're not identical brightnesses. Okay? In this case, it's the brighter bulb which has got the bigger resistance. If it's got a bigger resistance, it'll have a bigger voltage across it. These are connected in series, so they've both got the same current running through them, and the power dissipated by the bulb is equal to the voltage times the current. So by having a bigger resistance, that bulb on the left there has a bigger voltage across it, and so appears brighter because it's got a bigger power rating. Okay? Power, voltage times current. Okay? Now you don't have to connect bulbs in series. Very often we want to connect them in parallel. So this is a typical parallel circuit. We'd have 12 volts again, and this time the bulbs are connected up so that basically they've each got their own separate connection to that battery. Now in this case, if we have a look at the way the current goes, the current comes out of the battery from the positive terminal, gets to this point here, and then it can go one of 2 ways. So the current in a parallel circuit splits up. Some of it will go through the top bulb, some of it will go down the bottom, round the bottom bulb. The currents will join up again here, so the current going back to the battery is exactly the same as the current coming out of the battery, but the current through the 2 loops, or 2 branches, will be different to the starting current. Okay? Now again, at GCSE, the bulbs will be identical. So they will have, in this case, identical resistances. The current will split up depending on what the resistance in the circuit is. And the rule is that more current will take the path of least resistance. So in this case, because these bulbs are identical, half the starting current will go through there, and half will go through there as well. So in this case, the current through the 2 bulbs will be the same. Now, what about the voltage across them? Well, if you think back to our series circuit, we said that whatever voltage it gains in the cell, whatever voltage the current passes through in the cell rather, it has to lose on its path around the circuit. So if we go back to the parallel circuits, the current is still gaining a potential of 12 volts in the cell, so on every path around the circuit, it has to lose 12 volts. So if we follow it round through the top bulb, it has to lose 12 volts in going through that bulb. So it's back to 0 when it gets back to the negative side. Equally, if it takes the bottom path, once again, it has to lose 12 volts across the bottom bulb so that it gets back to 0 when it gets back to the bulb. Now what this means in a parallel circuit is that, in this case, each branch has the same voltage as provided by the cell. So each bulb in this case has the same voltage across it as provided by the cell as well. And if we have a look at that in parallel, we can see there that certainly 2 bulbs in parallel is brighter than 2 bulbs in series. Now this is for 2 reasons. As I say, they've both got 12 volts across them in this case, but this time as well, the resistance of 2 bulbs in parallel is less than the resistance of 2 bulbs in series. Okay, so there's actually more current coming out of the power pack to start with in this circuit than in that one. When the current splits in half, each of the bulbs here gets the same current as if we just had one power pack and one bulb on its own. So really, that bulb there should be the same brightness as both those bulbs there, even though, excuse me, we're still just using the one power pack on 12 volts. Okay? So, let's try and apply those 2 rules to a more complicated circuit. So here we've got a parallel circuit, but in the top branch, we've got 1 bulb, and in the bottom branch, we've got 2 bulbs connected next to each other. Okay? So first of all, what will the current do? Well, it'll come out of the positive terminal of the battery, it'll get to this point, and it'll split up. Now the resistance in this top path is going to be half the resistance in the bottom path, because we've got 2 bulbs in the bottom path. Now remember, most current will go the easiest route. So in the top path, we will get twice as much current as in the bottom path. Okay? So that's got a bigger resistance in the bottom, so it gets less current going through it. What about the voltage? Well, we've got 12 volts to start with, so remember, on any path around the circuit, the current has to lose 12 volts as well. So if it goes through the top path, there's only 1 bulb there, it has to lose all 12 volts across the bulb before getting back to the negative terminal where its potential will again be 0. If it goes to the bottom path, this time there are 2 bulbs, so it has to lose a total of 12 volts across those 2 bulbs. And again, if they're identical bulbs, which they will be at GCSE, the voltage will split across them equally. So it'll lose 6 volts going across the first bulb, 6 volts going across the second bulb, and we're back to 0 by the time it gets back to the negative terminal of the battery. Okay? What we can then do, if we can figure out using those things how voltage and current vary around circuits, is we then can apply various formulae like V equals IR to work out resistances of things, or currents of things, or voltages given the other 2. We can think about what proportion of current goes through one branch and the other, and we can think about where the voltages are in each circuit. Okay? So hopefully by watching this video, you've learnt a little bit about circuits, particularly how the voltage and current vary about both series and parallel circuits. And remember, it's only if the bulbs are identical there that it splits in half. At AS level, typically they will be different, and you will have to work out what current and what voltage go where. Okay? As I say, thanks for watching. Hope you've learned something. I'll make another video soon.